Hello students and welcome to this explanation. This is an explanation around the workings behind the calculations that are done on the financial calculator. So I think just knowing how to type information into your financial calculator doesn't seem to be the problem because students have asked for some YouTube video explanations, and I have posted some by other YouTubers who explain, for example, how a sharp calculator works, how the HP calculator works. But I think the problem really lies with students, even though they know how the calculator works, they're not quite familiar with why I'm typing the information into the calculator the way I am. And this is not a course for you to just parrot back information. The idea is that you should understand why you are approaching questions the way that you are. So one of the things that was brought under my attention was that students don't quite understand the difference between an example where we test what is mathematically called an annuity versus what is called a yield to maturity, right? So in this first example, I want to talk about the annuity first, because I think an annuity is quite easy to understand and it is very kind of technical. So if you are living your everyday life, this should be easy for you to understand. It's more technical and less mathematical. So an annuity is an instance where a loan is obtained at a specific time and both capital and interest are paid off over a predetermined period. So this means that you obtain a loan and now repayments need to be made. And by making repayments, you pay both for the capital part of the loan and you also pay the interest. All right. So this means each of the payments that you make. So if you basically look at a payment, each payment should consist of two legs. So there should be a bit of capital inside that payment, and there should be a bit of interest inside that payment. So I've put an example here. It says, suppose that a loan of 500,000 is taken out at an effective rate of 12% compounded annually over 3 years. Down payments are made annually and they are intended to cover both the capital and the interest. So this means that in your financial calculator, you type your future value to be 0. And we do this because when you make a payment, the payment includes both the capital and interest that you owe to the financial institution, which is whichever one you obtained this loan from. So by the time that you have made all the payments, which is now after 3 years, there will be nothing due for you to pay anymore. So you will owe nothing in the future because right now you are paying both for the capital as well as the interest. The present value is the value of the loan that you are receiving at the time when it's approved. So what is the loan amount that you applied for, and did you get this loan amount? So it's a 500,000 rand in this example. So this is the money that you get today. The future value is after the 3 years have lapsed. So the loan that you got to in current terms is 500,000. Then the effective rate was given, the time was given. That should not be too difficult. And then you needed to calculate the payment. So that would have been your compute function to get to the payment. And this payment now is comprising of both the capital and the interest because you're making down payments on the loan. So you receive 500,000 rand and then you make down payments on it. Each payment has a bit of capital, a bit of interest, and after 3 years you will owe nothing on this loan. Right, so that's an annuity. An annuity basically means that you make a payment and the payment reduces your debt. So your debt is the combination of both your capital and your interest. That is, simply put, your annuity. That's, I think, quite straightforward to understand. The other type of question that we have is the instance of a yield to maturity, right? So a yield to maturity is slightly less technical, and I think personally it's more mathematical. So a yield to maturity is an instance where a loan is obtained at a specific time and only interest is paid off over the loan period. The capital portion of the loan is repaid with a once-off payment in future. So if we look at our payment now, it only consists of one leg, and that is interest. It no longer consists of capital, right? Because the capital is paid with a once-off payment in future. And this is now after the loan period lapses. If we think about then, the payment should only consist of interest because capital is paid off in the future. If we are working with a yield to maturity, you should apply a certain type of logic. And this logic being that you are now thinking about calculating a present value for a capital amount that is due in the future. And this present value is the loan capital that you need to pay in future, plus the present value of whatever money you've wasted, or it is the capital loan the capital of the loan that you will pay for in the future, minus the present value of whatever money you've saved. So right now, this statement will seem very abstract. It will not make sense to you. And as I always say, accounting is difficult to explain in words, and that's why I have an example. If you are working with a yield to maturity, you will always find that there are two interest rates given to you in a question. So the first is an interest rate that is due by your institution or by you to this financial institution, and the other rate is a market related rate. So you will always have two rates. If you see the two rates, you know that you need to calculate a yield to maturity. So this example says, suppose that a loan of 500,000 is taken out at a rate of 12%, compounded annually over 3 years. So it's 500,000 Rand. It's taken out at a 12%. So this is the rate that we are paying or the business is paying. And it is the loan period is 3 years. Down payments are made annually and are intended to cover the interest. So look at this again, the interest only. It covers the interest only. And then it says the market-related rate for a similar loan is 11%. All right. Now I'm going to go back. I just want to select another color. I want to go back to my original explanation here where I said the present value that you're trying to calculate when you calculate your yield to maturity is the loan capital portion plus the present value of money wasted, or it is the loan capital that you need to pay in future minus the present value of the money that you've saved. So how do you know whether you've saved money or whether you've wasted money? Well, you need to go and look at the two percentages that are given to you, and these will be an indication. So the market expects of you to pay an 11% interest, right? So by average, you will find that the market rate is normally the average expectation. So if we look at the average, they say we need to pay 11% on average. Now, if we look at what the company is really paying, we are paying above average. We are paying a 12% interest. So that is above the average, above the norm, above the market, what the market expects, the market related rate. So we are in fact wasting money in this example because on average we should have paid 11%, but now the institution is charging us 12%. And why would this wastage happen? Well, mostly it's because of a business and its risk profile. If the financial institution believes that the business is more risky than the average than the same type of business in the average market, you're going to pay above the average in market interest rate. So this business is typically more risky than the average same type of similar business in the market. So here we are wasting money, and of course this is not done intentionally. It's sometimes just the result of the risk profile of the company. However, we are losing money. And the purpose of calculating a present value for your yield to maturity is basically calculating what is the cost of this loan and what is the cost that I am incurring in order to pay off this amount in future, or to pay this once-off payment that enables me to pay this once off in future. And here you will see that I've said we are wasting money. So the cost, the present value, the cost of this loan is the loan capital that you need to pay in future plus the money that you've wasted. So that is the cost, the wasted money plus the capital. But it can also be the other way around, and we're going to look at an example where you actually have a saving as well. But you can see in this question that we are paying above the market average, which means that we are actually now wasting money, could be inadvertently. So we're going to type into our calculators that the future value is 500,000 because this is the capital portion that my payment is not currently covering, because the payment only includes interest. Then I use my I as the market rate, because the market rate is also known as the effective rate. And in terms of IFRS 9, we are told that when calculations are done, we need to use the effective rate as our rate of amortization. Then there's a 3-year period, so that should not be too difficult. Then the payment. Now the payment consists of interest only. So I can go and calculate, but what is the interest that I'm paying? And this is, just mind this is your real interest, right? This is real interest. So this is what you are owing, the 500,000 times the real rate that you are paying, which is 12%. So the payment is easy to calculate. In the other example that we looked at, the payment was very difficult to calculate because it had a capital portion as well as an interest portion. But in your example where we are using a yield to maturity, you find that it's easy to calculate the payment because the payment consists of only interest. So we take whatever we owe times the rate, the actual rate or the real rate of interest that we are paying, which is then the 500,000 times 12%, which is 60,000. If you compute on your financial calculator, it will give you a present value of 512,21857. So now the question is, how did we get to this present value? And maybe if you understand this, it will be easier for you to answer your question, your questions in the test. How did we get to this present value, right? So I have made a summary of how we calculated this present value. So the following happens. We need to go and look at what is the difference between the actual interest that we are paying and the interest that the market expects of us to pay. So we are paying 12%. So this is your 500,000 Rand debt times the 12%. What does the market expect of us to pay? The market expects of us to pay 500,000, it expects of us to pay 11%. Right? So this is what we are really paying versus what the market expects of us to pay. So if we look at the difference for each year, so I've drawn up a table here. This represents year 1, year 2, and year 3, because this loan term is given to us in the question as 3 years. So if I look at every single year, we waste 5,000 Rand every year, because we pay more than the market would have expected us to. So we waste 5,000 Rand in year 1, we waste 5,000 Rand in year 2, and we waste 5,000 Rand in year 3. So now, because we are working with periods of time, we cannot assume that 5,000 Rand is 5,000 Rand is 5,000 Rand. We need to go and find what is the present value of 5,000 Rand for every year. So I start by saying, on my calculator, I type, the future value is 5,000, and I weigh at 11%. So this is at the market rate. So what is the market's present value of the money that I've wasted? I'm wasting 5,000 Rand at a market rate of 11%. And I'm wasting it 1 year from now. And that gives me a present value of 4,504 and 50 cents. If I look at my second year, the future value is again 5,000 because I'm wasting 5,000, but I'm wasting it 2 years from now at a market rate of 11%, and that gives me 4,058.11. If I look at my third interval, I'm wasting 5,000 Rand in the third year again. Now, I am wasting 5,000 Rand, but that's 3 years from now. So I need to go and discount every wasted amount for the years from which for the number of years from which it will happen between now, the current time and the future. So I'm wasting 5,000 Rand 1 year from now, another 5,000 2 years from now, and then another 5,000 3 years from now. And that gives me a present value of 3655.96. If we now calculate the present value of the loan, it's going to be the 500,000, which is the amount that I have to pay because my payment does not include capital. Then it's going to be the present value of every 5,000 that I've wasted over the 3 years because I pay too much interest, or I pay more interest than the market expects me. So if I take that 4,504, that 4,058, and this 3,655.96 cents, and I add it together, the cost of this loan, or the present value, aka the cost of this loan, is 512,218.57, which is exactly the same amount that we calculated on our financial calculators. So this is how your calculator gets to this present value. You've wasted money, and wasting money makes the cost of the loan presently more expensive. So it's the 500,000 you have to pay anyway, plus all the money, all the present values of 5,000 of the 5,000 rands that you've wasted over 3 years. But the opposite can also be true. You can actually save money as well. So here, for example, I've put a yield to maturity, which is the other way around. So let's look at this example. It says that suppose that a loan is 500,000 Rand is taken out at a rate of 9% compounded annually over 3 years. Down payments are made annually and are intended to cover the interest. Again, so if we look at the payment, it consists of only interest. So this is easy to calculate. The market-related rate is 11%. So what will I type into my financial calculator? Well, the future value that I need to pay with a once-off payment is this 500,000 Rand. So that's easy. I'm going to owe 500,000 Rand after the 3 years. Then the market rate is 11%. That's given. The time frame is 3 years. That's easy. Now, what is the payment? The payment is the interest. So that's what the real interest that I'm paying, right? So please note that. It's the real interest that I'm paying. So it's the 500,000 times the 9%, which is the interest rate that the business is paying. And that gives us 45,000. So if you type that into your financial calculator, you get a present value of 475,562.85. So what's happening in this question? Well, in this question, we're actually saving money because what are we paying? We are paying a 9%, but the market expects what? If we look at the market, it's asking for 11%. So we are paying less than the average. So if this is the average, right, so there's my average of 11%, my business is paying 9%. So this is below average, which means that I'm actually saving money in this instance. I am saving money because I pay less than the market expects of me to pay. So how did they get, or how did your financial calculator get to this amount? Well, I just need to copy it quickly from my example. I've also put a table out to explain how we got to that amount, right? So if we look at what's happening here, I look at my interest that is due. So the interest that is due in this instance is the 500,000 that I need to pay in future times my 9%. What does the market expect? The market expects 500,000 times 11%. So if I look at what is happening over a 3-year period, I'm saving every year because I pay a 45,000, but under normal market circumstances, they would have expected me to pay 55. So I'm saving 10,000 Rand every year that this loan is running for. And again, now I'm calculating what is the market's present value of the saving. So I said I'm saving 10,000 Rand 1 year from now. Then I'm saving another 10,000 2 years from now. And I'm saving another 10,000 3 years from now. So I type that into my financial calculator and say, I'm going to save 10,000 Rand 1 year from now at a market rate of 11%. What is the current value? It's 9,009 and 1 cent. If I save 10,000 Rand 2 years from now at a market rate of 11%, it's 8116.22. And if I save 10,000 Rand 3 years from now at the market rate of 11%, it's 7311.91. So now I'm going to take the present value, 500,000, and this is again the cost of the loan. The present value is the cost of the loan if we work with the yield to maturity. So what is the cost of the loan? It's the 500,000 that I need to pay in the future. But now I'm saving money. So if I'm saving money, it's making the cost lesser. If I'm wasting money, it's contributing to the cost. So because I'm saving money, I'm going to minus each of these savings that I make over the present value of each of the savings that I make over 3 years. And that gives me 475,562.86. So you will see it differs a mere 1 cent from each other. It should be due to maybe a little bit of rounding. But this is how they get to these values or to the present value. And it's important then to understand that yield to maturity is not the same. The yield to maturity is not the same as an annuity. So if we have an annuity, the payment is the capital and the interest, and by the end of the loan period, we owe a future value of nothing. Whereas with an annuity, the future value or the yield to maturity, I beg your pardon, the future value is the capital portion of the loan. And the present value is the capital portion of the loan minus the savings over the period or plus the wastage of money over the period. And the saving or the wastage depends on whether we are paying more interest than the market expects or less interest than the market expects. So I just wanted to give an overview so that you can understand, but how did we get to this present value? Something else that I want to talk about is this confusion that I saw that some of the students think that the future value and the fair value is the same. So I've given a question where I said that you had a loan, right? So if we look at the process, you have a loan. And then this loan is paid into your bank account. And then out of this bank account, aka this could also be a savings account, just FYI. And then this, out of your bank account or your savings account, you now buy this investment property, right? So I've given a question and then I gave a fair value of this investment property. And students used this fair value and they typed it as a future value there for their loan. This cannot be right, ladies and gents, because, and I'm going to do this, it's wrong, because if I have a loan, right, and I'm making payments, this loan is basically getting lesser and lesser and lesser. So let's suppose that this is an annuity, right? If I have an annuity, I'm going to make a payment and the payment will cover the capital and the interest. And each time I make a payment, I will have lesser debt, right? Then, if I have investment property, I can fair value adjust it. And normally investment property goes up in value. But I cannot argue that because the fair value of this property is increasing, I also now have to include it in my loan. What is happening in your loan account with your financial institution is totally independent of what is happening with the valuation of your investment property. You cannot argue that the fair value of your investment property has anything to do with your loan, because it's not going to matter what the investment property is worth. You will always owe an X amount on the loan depending on how many payments you've made and how many payments are still outstanding. So I do not want to see again that students confuse the fair value with the future value of a loan, because these two are two totally separate principles. The loan is simply paid into the bank account, and from that point forward, you can do with the money as you have concluded with the bank. You're going to buy a building or buy some kind of plant or buy some kind of whatever capital investment you have made, especially in terms of a specific loan. You have to buy that specific thing that the loan is for. But these two items, whatever you've done with the money and the valuation of it thereafter, is independent of what happens with the loan amount. So the fair value of the investment property can never be involved with your loan, because the loan is a separate entity from what is happening with the investment property. So I just needed to bring that under your attention as well. So please remember that the fair value is only connected to the investment property asset. What you owe on the loan is never affected by what your investment property is worth. The bank will never say, oh, you don't have to pay the loan because the investment property has increased in value. It will never happen, because these two are totally separate and unrelated. All right, so this is what I wanted to record. I just wanted to bring this under your attention, and I hope that you've learned something interesting from this video and that you've come to understand the principles of a yield to maturity versus an annuity and understand the mathematics behind it a bit better. All right, so I will see you in our next lecture. Keep well until then.